Okay, since we didn't finish the skills practice problems on Tuesday, we're going to quickly finish the second page of skills practice problems right now before we move on to our quiz review. So let's take a look at number 7. I gave you a hint yesterday or on Tuesday, that number 7 was just like number 4. This is a parabola that faces up, so it's concave up like a smile. And we have one really important point on this parabola, right down here in the bottom middle of this parabola. This point is where our graph crosses the y-axis. It's also the point where our graph crosses the x-axis, and it's also the point that's at the very bottom in the very middle of our parabola, and we would call that the vertex. So that single point actually represents 3 different things in this problem. It is our x-intercept, 0, 0, our y-intercept, and our vertex. And all 3 of those things we would write in the form of a point. So it's parenthesis, 0, 0, parenthesis. Pretty much the only thing we have to do now is identify our axis of symmetry, which always matches the x value of the vertex. So that's x equals 0. And then we need to decide if this is a minimum or a maximum. And this one is at the bottom of our parabola, which makes it a minimum. Okay, now on to number 8. Number 8 is a little trickier. We are looking at the Gateway to the West, the arch in St. Louis, the Gateway Arch. It has a general shape of a parabola. I don't technically think it's a parabola, but it's really close to looking like one. So I thought this would be a good model we could use for a nice example. This is obviously a concave down parabola. It's down like a frown. So that's an easy question to answer. But now let's talk about our intercepts. Our y-intercept is the point where our parabola crosses the y-axis. The y-axis is the vertical axis, the one that's going up and down. So we need to figure out where our parabola touches that y-axis. And the way we drew our graph, we designed our graph so that it crosses at the origin. So this big red dot that I'm drawing here, that is our y-intercept. And we write that in the form of a point, 0, 0. Now let's look for x-intercepts. X-intercepts are the places where our parabola crosses the x-axis. And that actually happens in 2 different places. The big red dot at the origin I already drew, and also over here on the right-hand side. So we have these 2 points are our x-intercepts, and now we have to figure out what these points are. Well, the first one's easy, 0, 0. We just did that one. But the second one, we're going to have to think about this. So some people just invented a unit system and said, okay, well, I'm going to call this x is 1, x is 2, x is 3, x is 4, and then just sort of estimated it based on their own unit system that they invented. But we don't have to invent a unit system. There's one in the picture. Does anybody see what I'm talking about? How wide is our parabola? 630 feet. So for this intercept, our x value, we're going right from the origin, 630 feet. So our x value is 630, and our y value, we're not going up or down, so our y value would be 0 at this point. So that big red dot represents the point 630, 0. Now let's find our axis of symmetry and our vertex. To do that, I think it's usually easiest to find the vertex first. So I'm going to draw this big green dot at the top of my graph. And of course, my axis of symmetry cuts right down through the middle. So let's see if we can figure out our vertex and our axis of symmetry. There obviously are no identifying marks here to tell us what that x value is, but is there a way we could figure out the x value? Okay, I see some people nodding. Can I get a volunteer to explain it to me, how we could find our x value of this vertex? Grace? Divide 630 in half. Let's break that down a little bit more. My parabola is 630 feet wide. The vertex is right in the middle of that 630 feet. So that very middle point of 630, would be 630 cut in half. So take 630 divided by 2, and you get 315. So the x value of the vertex is 315. What's the y value? Anybody see anything that'll help us figure that out? Okay, so the y value would be how high it is. So we went right 315 and then up how many feet? And it's represented in the picture somewhere. I'm sorry? It is. It's 630 feet. So this height is given to us. Our parabola is 630 feet tall. So the y value of this vertex would be 630 feet. Yeah, very good job on that. So our vertex is 315, comma, 630. Once you know the vertex, the axis of symmetry is really easy. It's just x equals, and then whatever the x value of your vertex is. So 315. And is this a minimum or a maximum? Maximum, because it's at the top of our parabola. Very good. All right, we have one more question to go over from this lesson, and this won't take us as long as you might think. We got a little dude here who wants to make a basket. He's shooting the basketball from this starting point. So I'm going to put a big red dot here where the basketball is starting. And then in order to make the basket, the ball has to end up at this point right here where it would go through the basketball hoop. So these are 2 points on our parabola. We know our parabola has to go through these 2 points. How in the world are we going to figure out what the rest of this parabola looks like? How are we going to find concavity, y-intercept, axis of symmetry, vertex? So you all tried to draw a picture of a parabola that would answer this question. Can I get a volunteer to tell me what you used as your vertex? Keaton, what did you use as your vertex? Just the point that you used. 0,5. So we're going to break this down. 1, 2, 3, 4, 5. That's our vertex. What's something, what do we know? What's that vertical line that passes straight through our vertex? Axis of symmetry. So our axis of symmetry, based on this vertex, would go right down through the middle of this axis here, the y-axis. Symmetry means our parabola has to be the same on the left and the right. So on the right-hand side, our parabola would go something like this. And if it's symmetrical, and we know it has to be symmetrical, the other side of my parabola would have to be 1, 2, 3, 4, 5, 6 units long. 1, 2, 3, 4, 5, 6 units long. Our basketball would end up right here, 6 units away from the vertex. So I think Keaton threw his ball a little too strong, a little too hard. But I understand the temptation, right? The axis of symmetry has to be right in the middle. Well, right in the middle of what? Can I get another volunteer to answer this question? What does our axis of symmetry have to be right in the middle of? In this picture, right here. Any volunteers? I know you guys know this. I talked to a few people about it. Jaina? The 2 points. These 2 points are at the same level, the same height. So our axis of symmetry needs to be right in the middle of these 2 points. So let's find the middle. The distance between these 2 points is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So if it's 10 units apart, the very middle of these 2 would have to be how many units away from our basketball? 5 units away. Thank you. So our axis of symmetry would be 1, 2, 3, 4, 5 units away. This vertical line is our axis of symmetry. Or another way of saying it is this vertical line is halfway in between my starting point and my ending point. It's the halfway mark, and that's where our vertex has to go. So I was hoping in this problem you would see that your vertex needed to be right in the middle, and that means we need to put our vertex somewhere along this line. So did anybody do that? Did anybody put a vertex somewhere on this axis? Okay, what was your vertex, Jana? 1, 1, 2, 3, 4, 5, 6. So you put your vertex right here. This would work perfectly. So the right-hand side of our parabola would exactly match the left-hand side of our parabola. They're the same width. They go down at the same rate. They end up at the same point on both sides. This is great. So if we were looking at Jana's page, our answers to these questions would be concave down, and the y-intercept looks like it's about 0, 5 point or 4.9. And we're just going to have to estimate that. The axis of symmetry is x equals 1, and the vertex is 1, 5. Now, your answers don't have to look exactly like Jana's, because you could put your vertex anywhere on this line. Let's say I wanted to put my vertex up here a little bit higher. All that means is that the shooter of this basketball he's arching it more. It's going to be more like a rainbow. It's going to be a lob way high up into the air, and it's going to come back down and make it. That is fine. So your vertex can be anywhere on this axis. You just have to make sure it's on this axis in particular. If you have it any more to the left or to the right, then it won't be symmetrical, and you have to have it symmetrical. So I'm going to circle the things in blue that might be different on your graph. The y-intercept y value and the vertex y value might be different on yours, but as long as you have the same axis of symmetry, you should be good. Okay, does that question now make sense to everybody? Why we needed the axis of symmetry where we did? Okay, great. So what we're going to do for the rest of class is work on the quiz review. So flip to Thursday's page in the packet. There are 5 questions here. Questions 1 and 2 are probably the easiest, and they get harder as you go. So my advice is to maybe focus, don't spend too much time on 1 and 2. Try to get 1 and 2 done really quickly, but try to focus most of your time on questions 3 and 4 and 5. Those are the ones that are kind of more challenging, and all of this material will show up on tomorrow's quiz. So spend some time working on these problems independently, and then closer to the end of class, we'll try to go over as many of these as we can. So I'm going to say this one more time in a location of the classroom where hopefully the virtual students can hear me too. If you get stuck on a problem, let's say you're on number 3 and you can't remember how to find the axis of symmetry, remember you can look that up. You can find it in your packet. Look back to previous days in the packet. All right, students, we have about 15 minutes left of class. So we're going to use the rest of our time to try to work through some of these problems together. Now, I was walking around checking your work, and it seemed like everybody was doing really great on problems 1 and 2. So as I go over problems 1 and 2, I'm going to do them really fast because I think you guys get it. I don't want to waste a bunch of time going through these problems super carefully. So take a look at number 1. This parabola is concave down like a frown. The y-intercept is the place where the graph crosses the y-axis. That happens at the origin. So the point where that happens is 0, 0. The x-intercepts are the places where my graph crosses the x-axis. Notice that that happens twice in 2 different places. The first time it happens is at -4, 0, and the second time it happens is at 0, 0. So we get 2 answers for the x-intercept. Now for the vertex and the axis of symmetry. We're going to kind of do both of these together because remember, they're very similar concepts. So I'm going to mark my vertex. I also noticed that a lot of you weren't actually drawing these on your graphs, which is okay. You don't have to draw them, but I find it very helpful to actually draw these things. So you might want to consider actually drawing these two on your pages. So you've got your vertex and your axis of symmetry. Remember, these cut your parabola right in half. So you need to make sure that you draw these right in the middle. Our vertex is at the point -2, 4, which means our axis of symmetry is at x equals -2. Your vertex is a point, but your axis is a line that shares the x value with the vertex, okay? So make sure you write these in the proper format. And finally, our vertex is a maximum since it's at the top of the parabola. All right, let's look at number 2 together. All the same questions. This one is concave up like a smile. And I apologize for the format of this graph, but it looks like the y-intercept is actually going to be up off the page somewhere. So we could kind of estimate this. We're just going to kind of use our eyes to estimate a value for the y-intercept. I think it's about 0,7, but you might have said it was 0,6 or even 0,8. I would accept any of those answers. This is just an exercise in estimating. So no big deal if you were off a little bit on the y-intercept. On the quiz tomorrow, you won't have to worry about this. If you get a y-intercept question, you will be able to see the y-intercept. So don't worry. That will be available to you. Okay, next question is about x-intercepts. Our x-intercepts are the places where our graph crosses the x-axis. And again, we're going to have to estimate these because these are not perfect values. They don't cut right at an intersection. So I think our x-intercepts are at about -4.5, 0, or -4.4, somewhere in that ballpark. And then also -1.5 or -1.6, 0. Your quiz tomorrow is multiple choice. So you don't have to worry about getting your answers completely exact. You just have to worry about being able to pick the right answer choice off of a multiple choice list. So as long as you can get your answer close, you'll be able to find the right answer from the list of options you have to choose from. All right, time for the axis of symmetry and the vertex. My vertex is this point right here. So the axis of symmetry is the vertical line that cuts right down through it. So right down through the middle of my parabola. The vertex point is -3, -2. And your axis of symmetry has to match the x value of the vertex, so that'll be x equals -3. And since this vertex is at the bottom of the graph, that makes it a minimum. Okay, time to move on to the more interesting problems. Number 3 doesn't have a picture. No picture at all. So we're going to have to find the axis of symmetry without a graph to cut in half. How do we do that? Most of us didn't know. At the start of class today, most of us didn't know how to do this problem. So where can we find the answer? Where can we find the method that we need to use? Nevaeh? Go to another page in your packet and find the formula. So we can find this formula on Monday's page of the packet. Monday is a great day to turn to because there's definitions, there's formulas, there's methods, there's tips and tricks. Monday is my usual go-to. So flip to Monday's page and find the formula for the axis of symmetry. Can I get a volunteer to tell me what that formula is? Joel? X equals -b over 2a. What in the world are b and a? Where do those come from? Connor, do you know?
The equation you're trying to solve.
The equation you're trying to solve. So what's a in my equation?
4x squared.
It's just the 4. A is just the value 4. And then b, Connor?
8.
Oh, we're on, yeah, -3, thank you. You're looking ahead to the next problem, aren't you? And then C is this other number at the end. We don't actually need that one in this problem, so just focus on A and B for now. we're going to take these number values and plug them in for A and B. So just to be really clear, I'm going to make the A and the B, I'm going to make them red. So it's very obvious exactly where we're plugging into. So if I rewrite this, I get x equals negative 3 over 2 times 4. Notice that what I'm plugging in, I'm putting in parentheses. You have to have those parentheses there. Whenever you plug a number in for a variable, you use parentheses. That is necessary. So time to simplify. On the top, I have a negative, which turns into a positive 3. And on the bottom, I have a 2 times 4, which turns into an 8. And we could leave our answer like this, x equals 3/8. You could also plug this into a calculator and get a decimal number. The truth is, I don't really know what form your answer will need to be in. You're going to have to look at the choices on the multiple choice quiz, and based on the answer choices that are available, you'll have to figure that out for yourself. If they're giving you decimal numbers, you might want to plug this into your calculator and get a decimal so that you can easily pick the correct answer off the list. That's our axis of symmetry. Moving on to number 4, this question asks us about the vertex. How do we find the vertex? If you don't know, where do you find it? In our packet? Yeah. What page of the packet? The first page. Let's flip to Monday and read the definition of the vertex. What does it say? I'm going to scroll up that way too. Zoom. Vertex. Our vertex is the point at the very top or the very bottom of the parabola. Okay, that's a definition, but that doesn't help us find it. Then it says the x value of the vertex matches the axis of symmetry. Okay, we're getting somewhere. What did we just talk about with the axis of symmetry? Nevaeh helped us find it. What did we have with the axis of symmetry? A formula. The formula of the axis of symmetry gives us the x value of the axis of symmetry. Well, the x value of the vertex is the same as the x value of the axis of symmetry. Remember, those two things are the same. The x value of the vertex is the same as the x value of the axis of symmetry. So this formula helps us find x for both of those situations. So let's go all the way back down to Thursday's page in the packet. Here we go. We use the same formula to find the x value of the vertex. X is going to be negative b over 2a. So our a value is negative 1. Our b value is positive 8. And we've got a c here as well, but we don't need that right now. We're going to put those a and b values in for a and b in our formula. So we get x equals negative 8 over 2 times negative 1. Fractions like this are pretty complex and they're difficult to type into the calculator properly. So I would recommend simplifying this a little bit before we try to type it in. So we've got a negative 8 up top, and we'll have a negative 2 at the bottom once we multiply those together. Now our fraction looks quite a bit simpler, and we can easily plug this into a calculator, or you can do it in your head. Negative 8 divided by negative 2, that will give us positive 4. So are we done with this problem yet? No, we want to find the vertex. The vertex is a point in the form of x comma y. We now know that our x value is 4. But how are we going to find the y value? And if you don't know the answer to this, you can find it in the packet under the vertex. Grace, do you have a thought about it? Great. Points have an x value and a y value. If you know your x value, you can plug that in to find your y value. That's what functions are. Functions are machines where we plug in an x and we get out a y. So I'm going to use a different color here. Our function is y equals negative x squared plus 8x minus 10. Well, we already know that our x value is 4, so we're going to put 4 in for x. Make sure you use parentheses everywhere you're plugging that 4 in, and use caution when you're typing this into your calculator. We're going to be typing in negative. Everybody get your calculators open. You'll want to try to type this in yourself. Negative parentheses 4 parentheses exponent 2, and then leave the exponent position. Then plus 8 parentheses 4 parentheses minus 10. What did everybody get? Positive 6. That's what I got too. So when we plug the x value 4 into the equation, we get the y value 6. So our vertex is 4, 6. Nicely done. We do have one question left, but I don't really think we'll have enough time to answer this in class today. So here's the deal. Fridays, we usually start class by diving straight into our learning check. We just, right off the bat, we start the learning check. But tomorrow in class, maybe it'll be a better idea to revisit this last problem. So if you haven't finished number 5 yet, try to finish it today. Get it done tonight and bring it back with you to class tomorrow. And at the very start of class, we'll look at number 5 together, and then we'll start our learning checks. And then tomorrow after the learning check, you guys can turn in your packets, and I'll grade every page of your packet all at the same time. So this is a reminder, if you haven't finished some of your packet, like if you skipped notes or if you didn't do the virtual learning activity yesterday, you still have time to do that because I'll collect packets tomorrow after the learning check. All right. Thank you, everybody, for a good class. I think you guys are doing well with this material.